Hi, hello everyone. Welcome to the today's session. Welcome to Unacademy. Welcome to Srinivasarao Sir classes. In this session, we are going to discuss about three-way hierarchy IP addressing. Last session, we discussed two-way hierarchy. Our 32-bit of IPv4 block is segregated into network part and a host part. So in this session, we are going to add in between network part and host part, that is a subnet part. So while you are doing a subnetting is the concept of three-way hierarchy IP addressing. We will see in this session. Please watch. Before entering into the session, let us say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Unacademy has created a wonderful digital platform to serve the dedicated students, which are from dedicated faculty members. So, my dear friends, myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects. Also had industry experience as a database side and a network side, with the relevant certifications in the same respective fields. Dear friends, throughout the journey of GATE, I taught in many premium academies with a high success rate. Many of my students got settled in higher positions in topmost MNCs as well as PSUs. You also can achieve such kind of success by clearing the GATE examination. So to clear the GATE examination, there is a need of the proper training and a proper guidance because it is a completely negative marking approach. So dear friends, please join into Unacademy and get the best quality content from the topmost educators. So to get admitted into Unacademy, there are two varieties of subscriptions, Plus and Iconic subscription. You may use either of the subscription. Iconic subscription is inbuilt having a Plus course. Once you become a subscriber to Unacademy, then you are going to get a live sessions like quizzes, mock test and mock sessions. So dear friends, utilize this opportunity what the Unacademy is providing to clear any kind of competitive examination. And according to the subscription wise, a plus subscription, 12 months and 18 months and 24 months subscription. If you use my referral code, then you are going to get a maximized discount opportunity apart from your top quality content. So after adding my referral code, you are going to get that these are the prices for 12 months, 18 months and 24 months. And according to Iconic batch, there are two kinds of subscription, 12 months and 24 months. In Iconic batch, and in addition to your plus course, there is a 1:1 personal coach program is also there. You're going to be given complete guidelines which assist you to clear your GATE examination. So my referral code is also eligible to that. Use my referral code, get the subscription in Iconic. So after applying my referral code, you are going to get it 12 months and 24 months. This is the fee cost. So dear friends, to clear any of your doubts, please come to us using this form. Fill this form, then we are going to clear all your doubts. Let's Crack GATE CSC is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the admission into Unacademy. Hit the bell icon for latest notifications and updates. Let us start. What is a three-way hierarchy? I already told you the meaning of a three-way hierarchy. When you think that I need three-way hierarchy, which is nothing but you're having as usually two-way hierarchy, that is a network part, and the other part in your two-way hierarchy is a host ID. In addition, we are having a one more part, that is the meaning of three-level hierarchy IP addressing, which is a subnet ID. Sometimes we also may use for supernet ID. This is how you can able to distinguish, my dear friends, two-way hierarchy and three-way hierarchy. So once you see that mobile number, I said the last number is like this 8790, some number like 123456, and you know what is the network it is. The network it is Airtel, and what is the host ID it is. This is the host ID. In middle you are being given a roaming number, that is a state identification number. So you will be given a roaming ID. However, your mobile number is having a three-way hierarchy. Actually, it is a four-way hierarchy. We are also having a country code also. However, your mobile network has got a hierarchy of your numbering system. Our IP address also got two-way hierarchy and three-way hierarchy. So when you talk the three-way hierarchy, we are having the concept of network ID, host ID, along with that subnet ID or supernet ID. Now let us see what is the subnet and how to identify subnet ID and how to see that subnet broadcast address. We will discuss in this session. This is one of the part today we are going to discuss. There are two parts you are subnetting. One part is FLSM, then second part is FLSM continuing. After that I will start VLSM part 1 and VLSM part 2. So in this session we are learning subnetting in the form of FLSM, fixed length subnet masking. So what is the subnet? So when you talk a concept of a subnet work, so subnetwork is nothing but your large network is divided into smaller parts. So whenever your large network divide into smaller networks, I see that the circle size is also very smaller. And whenever you have this kind of a situation, your large network is divided into smaller networks, is the concept of subnetting. Subnetting is nothing but a reduction of your single large network size who is having a huge number of HIDs. We want to segregate, cut them and place it in the different subnetworks. So your host IDs are being segregated here into different networks is the concept of what? Subnetwork. You may get a doubt that what is the advantage? We will see what is the advantage and what is the disadvantage. We also will discuss. What is the idea? Subnetwork is nothing but it is a part of your large network. A large long network is divided into smaller parts of networks is the concept of subnetworking. So to perform subnetworking, there is a requirement of subnet mask. So what is the subnet mask? We will discuss. So let us see that subnet working or otherwise subnet masking both are same. So split a large network into smaller subnetworks. It is a mechanism to segregate your HIDs from large networks and push them into the smaller parts. Is the concept of subnetting. It is a mechanism to manipulate HID bits of your subnet mask from zeros to ones is the concept of subnetting. So total number of subnets are nothing but the number of ones which are there in your HID path is nothing but total number of subnet. Okay, my dear friends. So what is the advantage? Routing decisions are easier, traffic can be reduced, and instead of managing a larger network, I try to branch it. Therefore, you are going to have a branch offices, and every branch office is managed by branch managers. Right here, branch manager is nothing but subnetwork ID, and these are all the branches are part of your main office or main subnet. So identification of a host in the network is easier. Time complexity to identify host is minimized. But what is the drawback? The one very important drawback is wastage of HIDs due to allocation of subnet ID and subnet broadcast address. Let me show you now. I'm talking about Class C network. It is a single network only I am talking. It is a single large network. So naturally the Class C network can able to have a maximum of 256 HIDs, no doubt, because it is a triple N and a HID. This HID is nothing but which consists of 8 host IDs, which can able to give you 2 power 8 HIDs, which is nothing but 256 HIDs. This is the point number 1. Now I'm going to split this 256 HIDs into your requirement. So I want to do 2 parts, which is nothing but 2 subnets. When you do 2 subnets, one part is a 128H and the other part is a 128 HIDs. Please observe, this is a tricky concept. Observe carefully. If I am making your 256 into 4 parts, so I am doing a 4 parts, it is nothing but 4 subnets. You are having a 4 subnets. Each subnet is divided by 64. That means every particular subnetwork is capable of 64 employees or nothing but 64 IP addresses or nothing but 64 HIDs. Likewise, you can do 2 subnets or 4 subnets or 8 subnets or 16 subnets. That is up to you. Now let me show you what is the advantage with subnetting. I am taking a single large network which consists of 256 HIDs, which consists of 256 HIDs. Therefore, each computer is connected and they are being assigned with IP addresses. 256 IP addresses I can have from Class C, which starts with 0 and which ends with 255. We know that 0 is nothing but a network number and 255 is nothing but network broadcast address. So you cannot use 0 as a usable IP and 255 as usable IP. You have to stop exactly at 254. Now a packet has come here. Observe. Packet is arrived to network with a destination address. Observe carefully. The destination address, network, HID I am doing because in Class C, if you observe Class C is nothing but network and HID only. So I am giving HID as 250. So now it start identifying where is the 254 or 250. So it start comparing with 1, it's not, 2, it is not, 3, it is not, and so on it goes. Somewhere you will find 250. Now therefore this packet will be handed over to this particular 250. Now you observe carefully, there is one important point. What is that? So we are inquiring that where is the 250 availability. Therefore your time complexity to search the node is worst case order of n. So here there are 256 HIDs are there. Your maximum time complexity is a order of 256 if it is available. If not available, it is going to give you an error message that the host ID is not available, right? So I'm going to split into smaller units. What is the advantage? We will see. If you see that one large network, if you divide it into smaller branches, the management is very easy and the work segregation is also very easy. Now if I am saying this is your 256 HIDs, this is your 256 HIDs are split into 4 parts. Assume. So my dear friends, the management, how simple it is, you will understand. I did a 4 subnets and each subnet is equally segregated with 64 HIDs or nothing but 64 employees in each particular branch. Now therefore, this consists of 64, this consists of 64, this consists of 64 and this consists of 64. Now you see, this is having address range from 0 to 63. This is having address range from 64 to 127. I am taking 64 blocks, 64 block size. This is having a 128 to 191. This is having 192 to 155. Observe this. Now a packet has arrived to the network. Packet has arrived to the network with a destination address as, please understand, this is a class C. We are having a formation triple N and H, right? Now your destination address is a triple N dot 250, same number I am taking. Please understand, here also same number, there also same number. And now where I am going to search, I know that 250 is one of the IP which is existing in this particular network, right? Therefore, I will not check in other particular networks or subnetworks. I just directly, this packet will be handed over to this particular subnetwork one. So what is your time complexity? Your time complexity is minimized. How much? Worst case, only 64 HIDs I am going to compare, because your 250 is one of the computer which is in between 192 and 255. Okay, my dear friends. So this is how you can able to minimize it. This still I can able to minimize using this example. A large network which consists of 256 HIDs, which is divided into 8 parts this time. So which is divided into 8 parts. 1, 2, 3, 4, 5, 6. One more I am doing 8 parts. Therefore, your class C network can give you 256 HIDs, and I am doing for what? 8 subnetworks. So when you do 8 subnetworks, your branches are increased now. We know the rule. What is the rule? If subnets are increased, then your time complexity is decreased automatically. So each network has got how many HIDs? 32 HIDs only. So what is your time complexity? Your time complexity is still reduced. How? Let us allocate the numbering. So first you are having 0 to 31 and 32 to 63 I will keep here. 64 to 95 I will keep here. 96 to 127 I will keep here. 128 to 159 I will keep here. 160 to 191 I will keep here. 190 to 223 I will keep here. Please see that every particular part is 32. And 224 to 255 I will keep here. Now these are the segregations are there. Now let us see the same question. What is that? A packet has arrived to the network with destination address same, network 250, same number I have taken. Now this time I come to know very easily where this 250 is there. Then this 250 will be transmitted to this particular part only. Therefore, what happened? Your time complexity, if you observe, only 32 HIDs I need to verify. So your time complexity is only order of 32. Earlier, order of 64. Earlier, order of 256. Worst case, I am telling you. This is how you can minimize the time complexity while searching the nodes, my dear friends. Therefore, subnetting is one of the best thing while you are transmitting your data packet easier. Instead of searching in entire network, simply it will go and stick it onto particular subnetwork one. So this is the ideology of subnetting. But what is the problem with subnetting? The problem with subnetting we already seen. What is that? Wastage of HIDs. Come to the previous example. If I am using as a single network, this is your single large network. No splits ID. Now, how many host IDs are unusable here? Only two are unusable. Please understand. Only two HIDs are unusable. One is a starting block number, the other one ending block number. That is n dot n dot n dot 0 cannot be used. N dot n dot n dot 255 cannot be used. Right? Only two HIDs are unusable. So in this example, how many hosts are unusable? Starting of the block, ending of the block. That means you cannot use this, you cannot use this. You cannot use, you cannot use. Starting number, ending number cannot be used in any particular subnet. Therefore, how many host IDs are unusable? So 4 subnets into 2 host HIDs are being hosted here. So how many are unusable? How many are unusable is very simple. A number of subnets into 2. Number of subnets into 2. So here there are 4 subnets. 1, 2, 3. And every subnet is wasting 2 HIDs starting of the block and ending of the block. So total here 8 HIDs are wasted. If you look at next one, how many subnets you got? 8 subnets you got. So how many host IDs are unusable here? Please understand how many HIDs are unusable here. 8 parts into 2 HIDs. There are 16 HIDs are unusable in this. This is the one of the problem with your subnetting. As your subnets are increased, as this is your advantage. If subnets are increased, time complexity is decreased. But what is the disadvantage? The disadvantage is if subnets are increased, then automatically wastage of HIDs are also increased. Wastage of HIDs are also. If I do 40 subnets, 40 into 2 HIDs are wasted. If I do 100 subnets, so 100 into 2, 200 HIDs are wasted. Still you can use only 6 HIDs according to the class C network. So very big problem with the subnetting, wastage of HIDs in this. So now we will see that how to identify whether a given network is a subnetted or not subnetted. See. So my dear friends, whenever I say three-way networking you are using, that means three-way hierarchy you are using, you will get 3 important fields. Network number as usually, according to class C if I am speaking, and HID is as usually according to class C I am speaking. Middle you are going to have subnet number, right? So how to identify subnet number? What are the IP addresses which are eligible for subnet number? We will see in today's session, especially in class C. So which classes are eligible to do subnetting? This is also very important. Which classes are eligible to perform subnetting? They are A, B, C classes, not D and E. A class is eligible, B class also eligible, C class also eligible, but D and E are not eligible because they are belonging to what? A single group. Only ABC can be put it into two-way as well as three-way hierarchy. Now let me show you which is the main component is involved in a subnetting and how to identify subnets, IDs, and how to see that how many number of subnets we are going to get it. So come to a concept called subnet mask. So subnetting is a completely, it depends on subnet mask only. So subnet mask is nothing but masking of HID bits from zeros to ones is the concept of subnetting, right? First, let us get confident in subnet mask. What is a subnet mask? It describes that the size of your subnet or how many HIDs are there in your subnet or how many IP addresses are there in your subnet. It is used in subnetting and supernetting. What is the subnet mask? Default subnet masks are there according to A, B, C classes. Let us see class A. Class A is nothing but, if you understand, class A is a network with three HIDs. That means this cannot be disturbed. Therefore, so we can have 32-bit zeros, but as this is restricted, network path is restricted, this is a fixed value. But this can have 8 zeros, and this can have 8 zeros, and this can have 8 zeros. That means how many number of zeros are there is nothing but how many number of HIDs are there. In class A, you are having these many HIDs. How many HIDs? 2 power 24 HIDs are there. So therefore, what is your default mask in class A? In class A, default mask is N with triple zero. So instead of N, what I am going to write? 255 I will write because it cannot be masked from zeros to ones. Therefore, your default mask of your class A is this, right? According to class B, it is a double N, double H. That means this is the fixed portion. It cannot be manipulated. This is the fixed portion which cannot be manipulated. But this has got 8 zeros. I can manipulate. This has got 8 zeros. I can manipulate. Therefore, how many HIDs are there? This is your number of HIDs. How many HIDs are there? I can say that number of HIDs are 2 power 16. So what is the default mask here? The default mask here is 255.255 dot. It is a 0.0. Right? Let us see class C now. So when I am talking a class C, it is nothing but triple N dot H. So the first three octets are reserved for networks. You cannot able to do any manipulation on your mask. So it is a 355 and I have got 8 zeros here. So how many HIDs? Your HIDs are nothing but number of zeros are there in your mask. There are 8 zeros, 2 power 8 HIDs. So what is your mask now? It is a 255.255.255.0. Okay. This is what is shown in this table. Observe. Class A 255 dot, because all ones means 255, and 0.0.0. I can manipulate these numbers. And in class B you cannot manipulate this, but you can manipulate these two octets. In class C you cannot manipulate these three, but you can able to manipulate this. It is a 255.000, 255.255.00, 222.55.0, because in IPv4 we are having 4 octal system. 4 octets you are having: octet 1, octet 2, octet 3, octet 4. My dear friends, I want to ask a question to all of you. Please answer. Let subnet mask is subnet mask of a network is 255.255.0.0 and 255 dot and 255.255.0, and another one 255.0.0.0. Now answer in this example, how many HIDs are there in this? Dash HIDs. Here also dash HIDs. Using this mask dash HIDs. So there are 8 zeros in third octet, 8 zeros in fourth octet. So number of HIDs are 2 power 16. Here only 8 zeros are there, 2 power 8. Here 24 zeros are there, 2 power 20. This is how you can understand what is the network size just by taking a subnet mask. You need not have the classes. You can also say using a subnet mask will tell you what is the size of your network, how many host IDs are there, or what is your block size. Let me give another example. Let subnet mask is given as subnet mask is given as 255 255 255 192 dash HIDs. Don't say that 0 HIDs has no zeros are available in your mask. If you are having a doubt like that, it is a wrong approach. There are some zeros here, no zeros. 255 means all 8 ones. No zeros, no zeros, but it's not all 8 ones. Let me write the solution. This is one of your previous GATE question. So first let me write your 255. Your 255 means all ones. Here also 255 means all ones. Here also 255 means all ones. But here you observe 192 means it is a double one only. Double one, and the remaining are zeros. So how many zeros are there? There are 6 zeros, 2 power 6, which can give you 64 HIDs. So this is how you can decide what is a network size or a block size or how many HIDs are there. Here, don't think that there are no zeros, but there are zeros if you write them into the binary. Now, what is the subnetting? How to identify whether the subnetting is happened or not? If I am saying subnet is happened or not, subnetting. Subnetting is nothing but masking of HID bits of subnet mask from zeros to ones. Right? This is the hint to identify whether it is subnetted or not. Okay. And now there are two varieties of subnetting is happened. Before that, let us see that when you are using a subnetting, so every subnetwork has subnet number. This is nothing but starting address of your subnet block and subnet broadcast address. Subnet broadcast address. So subnet number is nothing but starting block of your subnet, starting IP of subnet. You cannot use. It is used to identify subnetwork number. And the next one is what? Ending number. Ending IP of subnetwork. Clear na? So every particular subnet is associated with a two reserved numbers IPs. They are starting number and ending number. So you want to do the subnetting. Let me show you. For example, let mask is given as 255.255.255.255. Let class C mask. It is given as 8 zeros. My question is it subnetted? The answer is no. Why? Because according to class C, this is a network part, network part, network part. This is your HID part. So HID bits are not masked from zeros to ones. The meaning of subnetting is that only. So subnet mask, you need to manipulate HID positions from zeros to 1. Here it is not manipulated from zeros to ones, hence it is not subnetted. Now let me give you one more. Let class C subnet mask is given as 255.255.255.192. Now, is it subnetted or not? Can anybody, those who are online, please reply with answer. Is it subnetted or not? So we will say, according to class C, the given mask is 255.255.255.192 means 1160. So this is your HID part. And they are your NID parts. So NIDs are not manipulated. NIDs you should not manipulate, but HID is manipulated from zeros to ones. Actually, it's supposed to have a zeros here, and zero is being manipulated as a ones. Hence, we come to know that it is a what? Subnetted. Subnetted with how many bits? With the 2 bits subnetted. This is very important. How many bits are manipulated from your HID part to your subnet mask? So it is nothing but 2 bits are manipulated zeros to ones, and so we confirm that it is a subnetted. If anybody asks you, there is a question that, for example, let class B mask is given as 255.255.0.0. We know according to the class B, the default masking is double N, and these are HIDs. And HID is not manipulated not from zeros to ones. It is not at all manipulated from zeros to ones. Therefore, I can come to know that is it a subnetted? So our answer is no, because HID is not manipulated here. It's not subnetted. This is the hint to you whether the particular network is a subnetted or not. It's basically depends on your subnet mask of the respective classes. Clear? Now if I give you another example, the example is saying like this: let class B mask is given as 255.255 dot and 254.0. Is it subnetted or not? Is it subnetted or not? You know the hint. I already told you. What is the hint? According to class B, your subnet positions are double N, and this is HID part. Your HID part, instead of 0, there is some number is there. What is that number? 254 is there. That means it's supposed to be zeros. According to the previous example, it's supposed to be zeros. But here, it's not 0. There is something, digit is given in decimal. That means it is manipulated. Hence, I can come to know that, yes, subnetted. So, with how many bits subnetted? So, 254.0, you are having 8 zeros here, and you are having a 1, 2, 3, 4, 5, 6, 7, 0. This is your 254 in binary representation. So how many bits are subnetted? Yes, it is a subnetted with 7 bits. So 7 bits are manipulated from zeros to ones is a concept of what? Subnetting in class B. So if I am saying another example, that let class B is a given mask, you need to know first of all whether it is subnetted or not. Class B is a given a mask as 255.255.254.254. Now he is asking, is it subnetted or not? So come to the default masks. Is it subnetted or not? You know default mask of your class B is nothing but n.n.h.h. That means it's supposed to be 255.255 0.0, but instead of 0 there are something is manipulated. Therefore I can say that yes, it is subnetted. Yes, it is subnetted. With how many bits? With how many bits? Total 14 bits subnetting. It is a 14 bits subnetting. Therefore your total subnets, now I am adding extra point. Your total subnets are 2 power 14, right? So it is almost all 16,000 subnets we performed according to this. Roughly 16,000 subnets. Well, friend, let us see the last example. Let class A mask is given as 255.0.0.0. We would like to know, is it subnetted? Our answer is straight away no. Why? Because it is a default mask. What is the default mask of your class A? Class A default mask is nothing but N with triple H. and your triple H is given as 0, no other manipulations are there, hence it is not subnetted. Simple answer. Now I will give you with a different example like this. Let class A is given as 255.128.192.224. Is it subnetted or not? Yes, straight away I can say that yes, subnetted. Because instead of 0 in second, third and fourth octet as it is representing for host, some other number is there instead of 0, non-zero value. So yes, it is subnetted with dash bits. Now I will tell you. So 128 means, so 1 is on remaining zeros. And 192 means double 1 and 6 zeros. And 224 means triple 1 and 5 zeros. Therefore, we understand 1 here, 2 here, 3 here. So we can understand, yes, it is subnetted with a 6-bit subnetting. So when I say 6-bit subnetting, your total subnets according to this, your total subnets are 2 raised to 6, which is nothing but 64 subnets. But my dear friends, now tell me, can I do subnetting like this? It is a meaningless subnetting. It is a meaningless subnetting. Why? Because we are performing a random splitting, not uniform splitting. Your current operating system is not going to allow you. This was earlier subnetting, but Windows XP after that, we have seen that your subnetting supposed to be consecutive ones, not a random splitting. So random splitting we must not do. Why? Because wastage of HIDs are more in this. That's why it is a valid subnetting only, but you cannot able to implement in real time like this because a lot of wastage is happening in this. So there are two varieties of subnetting. Now let us see that we already know what is a subnetting and which part to be subnetted and what is the component we are using, subnet mask component we are using. According to the class you need to subnet it. These are the important rules we learn. Now your subnetting are two varieties. One variety is fixed length subnet masking. The other one is variable length subnet masking. Right? So some people will also call it as uniform splitting. Uniform splitting, and this is called random splitting. Right? So what are the problems with the random splitting and what are the benefits with the uniform splitting, we will see. So whenever you say that FLSM means uniform splitting, I can able to do, right? So let us see, today's session is based on FLSM only. So what is the concept of FLSM? Very important questions. Please do practice more on FLSM, but VLSM 5% chances, but 90% cases FLSM you will get. It is known as fixed length subnet masking. Fixed length subnet masking. What is the concept? Is observe. The concept is that the size of subnetworks, are equal to all subnets. Naturally, it is measured in the form of exactly 2 to the power of zeros. or 2 power 1 or dot dot 2 power n. Exactly, you will get the answer. Now, what is the advantage with FLSM? The advantage with FLSM is proper utilization of HIDs. Proper utilization of host IDs. Right? And how to identify whether I am doing FLSM or not? A simple trick. What is that? Uniform splitting is a concept of FLSM. So let me show you one sample example for FLSM. I am taking a large network which is divided into 4 parts. So let us say that 256 HID network I am having. You may guess what is the class I am using. I am using class C network, no doubt. And I am making into 4 parts. When you do 4 parts, then what will happen? You are going to get equalized HIDs for all the 4 parts. This will get 64 block. This will get 64 block size. This will get 64 network size. This will get 64 HIDs. All are synonyms only. Block size, network size, or host size, whatever it may, or network span. So this is what is the meaning of what? FLSM. The same example if I am taking as a class C, I am having 256 HIDs are there, and which is manipulated as like this. One subnet is having 32H and another subnet is having 62H and another subnet is having a 64H and another subnet I need 128H. So if you see that your subnet 1 and your subnet 2, subnet 3 and subnet 4 are having a variable length of size of blocks. So this is called as a what? VLSM. Variable length subnet masking is the concept of this. Why? Because the subnetwork sizes are variable here, not the fixed. It's not equal to all the subnetwork. So whenever you design like this, it is a VLSM. This is also acceptable, no doubt. But when you do like this, so random splitting, you better use it. Or in contiguous splitting only, you can also form what? Your VLSM. So I am doing the VLSM can be done using a random splitting, and I can also be done using a what? Uniform splitting. But uniform splitting in my case is, so don't think otherwise that uniform splitting means all the total size of the blocks are same. Yes, I agree. It may comes under into FLSM. But VLSM, what I am saying that, for example, let me put you one example here. I have taken a network which I want to divide as like this and which I want to divide like this. This I want to take a 128 HIDs. This I want to take 64 HIDs. Please observe here. So outer I am doing VLSM. This is a different size and these are a different size, but these two are same sizes only. So inside I am doing FLSM, outside overall I am doing VLSM. So you can also able to manage networks like this. So in this session, I want to explain first of all FLSM with a what? Consecutive splitting, serial splitting in the class C network, right? Today we will see that how class C is going to be subnetting under FLSM case. What is your class C? Your class C notation is network, network, network and HID. Therefore, your subnet mask is supposed to be, this cannot be manipulated as it is a network part. This cannot be manipulated as it is a network part. This cannot be manipulated as it is a network part, but HID I have 8 zeros. Doubt. If I am doing like this, it is a 0-bit subnetting. It is a 0-bit subnetting. So I am doing a 1-bit subnetting. This is a fixed. We are not going to touch the left hand side 3 octets. Our concentration is this. Consecutive splitting from left towards to right is a concept of FLSM. Observe. Consecutive splitting from left towards to right, masking zeros to ones of your HID part. First, I am making it on. It is 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now I am manipulating the first MSB of your HID and remaining are off. When you do like this, you got a new mask, that is a 255 dot, 255 dot, 255 dot, 128. The 128th position is being masked. This is a 128th position. You know, 1, 2, 4, 8, 16, 32, 64, 128th position. So I did 1 bit subnetting there. 1 bit is subnetted. Now if I am making consecutive ones from left towards to right, so 2 bits are manipulated. What is the new mask? 255 and 255 and 255 dot 192, which is a 2-bit subnetting. And I can do 3-bit subnetting and 4-bit subnetting, 5-bit subnetting, 6-bit subnetting, and 7-bit subnetting. And if I do 8-bit subnetting, it is invalid. Why? Because when you do 8-bit subnetting, you are going to get a mask called LBA. 255, 255, 255, 255. So it is a completely been masked. So you are not having any kind of host IDs to put them into the particular network. Therefore, according to the subnet, you have to stop it at a particular position. Which position? I'm going to tell you. Observe. So its meaning is 224. I'm doing a 3-bit on, 5-bit off. This is 240, 4-bit on, 4-bit off. This is 248, 5-bit off, 5-bit on, 3-bit off. And this is 252, 6 bits on, 2 bits off. So you need to stop here. This is your restriction point. Don't take 254 and 255. They are not used to segregate any kind of HID. So you need to stop exactly at where this particular 6-bit subnetting is the last ending point to do the subnetting. Why? You may get a doubt. I will explain in the next session why you cannot use 254, that is 7-bit and 8-bit masking. Okay, my dear friends. Now listen, what is the advantage with FLSM we have seen? I will show you. Now HID part is manipulated from left towards to right by masking zeros to ones in class C. So class C, I said that 255.255.255.224, yes, dash bits are subnetted. So our answer is, we know 224, I already given a format which is nothing but 3 bits are subnetted. Therefore 3 bits are subnetted. This is your answer. So once you know that 3 bits are subnetted, which means 1, 2, 3, every subnet has got 5 combinations here. Don't forget that. Every subnet has got 5 zeros combinations. These zeros are nothing but HIDs, and these ones are nothing but subnet. And the first three parts are nothing but network. This is why it is called as a three-way hierarchy. First part is a network part. Second part is your subnet part. And the third part is your host part. Okay, my dear friends. So 128th position, comma, 64th position, comma, 32nd position are subnetted. You need to know the positions carefully. Are subnetted. For every subnet, you are having 2 power 5 HIDs. Now my question is, according to that, a number of subnets how many? Your answer is, as 3 bits are manipulated, so 2 power 3. And for each subnet, how many HIDs? Number of HIDs per subnet is nothing but each subnet has got 5 zeros combination. So 2 power 5 minus 2 is there. Why minus 2? That I will explain in the next section. Therefore, if you look at here, I have got a big network which is divided into, according to the previous section, 8 parts are being divided. And each part is got, total is a 256 divided by 8 part. Every part is responsible of what? 32H. Every part is responsible 32H. If you look at the block sizes or network sizes, every block has same number of HID. This is the concept of fixed length subnet masking. The length of your network or length of your subnetwork is what? Fixed. So we will continue the FLSM in the next session. Don't miss the FLSM and VLSM and subnetting and supernetting classes. Please use my referral code to get the admission into Unacademy so that you will learn many more things apart from this. My referral code is Sankara, and stay tuned to Unacademy. Stay tuned to Srinivasarao Sir classes. Once you learn the IP addressing, you will be an expert. You also can able to give lectures on online or offline everywhere. And I will be very proud that many of my students become online and offline mentors. Really, it's a wonderful situation. So you also can become. Stay tuned to me. Use all my experiences. We will meet in the next session. Thank you very much.